Now I will start our company presentation, which is first and foremost, I will present about the company logo. So the color of our company logo is about turquoise color, which bring the means of technology and innovation, trust and reliability, precision and clarity, and modernity and freshness. For our company names, in the logo, EVOLEC. Evo is a short term from evolution, which means continuous improvement and adaptability. It also brings means of dynamic adaptation, progressive development, growth, and future oriented. Next, under the Evo terms is precision. The word precision bring means of core value or offering, and it also synonym with the IR 4.0 relevance. For the 5 star in our company logo, it tell the customer about how excellence and quality our product are made, perfection and high standards, and our rating and trust for our customers. Next, moving on to the terms of Sendirian Berhad, it shows that our company is a legal entity, legal framework, our company credibility and accountability, and it shows compliance to our company. Lastly, for our company logo means is leg terms. Leg is taken from legacy, which means about foundation and expertise. It also means in our logo about valued heritage, experience and reliability, and enduring quality. Now I'll present about our company details. So what is our purpose and where is our location? Our company is an expert in automotive industry. We build high performance ICE and hybrid compatible engine components. Our company location is at Batu Kawan Industrial Park in Penang, Malaysia. And our product focus is turbochargers, forged piston, crankshafts, precision gear sets, engine internals for ICE and hybrid systems. Our target market is performance car, motorsports industries, and global tier 1 automotive suppliers. Our company motto is precision in evolution, built on legacy. As shown in the slide, our company mission is to empower industries through innovative Industry 4.0 data system and digital solutions, driving unparalleled precision, operational efficiency, and transparent management, while fostering a commitment to sustainable practices. And our company vision is to be a recognized leader in transforming industrial operations, pioneering the future of intelligent and sustainable manufacturing through advanced data analytics and unwavering precision, built upon a foundation of proven expertise. This is our company organizational chart. Our company are being led by a managing director named Nur Alia Sohaila, and followed by other 5 director or manager who is expert in their own field. So the head of human resources is Emilia Liza, Ama as a lean and digital transformation manager, Aminuddin as technical director, Muhammad Ashraf as operation manager, and me myself, Muhammad Haziq, as QA and QC manager.
At Evolec Precision Sdn Bhd, our company policy is built on 6 core principles that guide everything we do. We are committed to quality, delivering precision engineered components that meet the highest standard. Second, we ensure a safe and healthy workplace, prioritizing the well-being of all our employees. Third, we adopt a mindset of continuous improvement, applying lean and kaizen practices to eliminate waste and drive efficiency. Fourth, we believe in data-driven decision-making, using tools like Google Forms and Sheets to track, analyze, and improve our processes in real time. Fifth, we take environment responsibility seriously, complying with all regulation and minimizing our operational impact. And finally, we foster a culture of employee empowerment and integrity, where every team member is encouraged to take ownership and act with professionalism. These values help us stay competitive, compliant, and committed to excellence in the global automotive industry. Our business approach at Evolate Precision is centered on delivering high-quality precision automotive components while maintaining operational excellence through lean and digital innovation. We apply lean manufacturing and world-class manufacturing principles to reduce waste, improve efficiency, and ensure product reliability. What makes our approach unique is the use of cost-effective IR 4.0 tools such as Google Sheet, Google Form, and Looker Studio. It is to manage tools and part replenishment without needing expensive ERP system or industrial IoT. By integrating this platform, we developed a digital Kanban system that enhances visibility, accelerates response times, and empower operators to contribute directly to workflow improvement. This approach is not only streamlined to our production, but keep us agile, scalable, and responsive to the demands of the global automotive market. Ultimately, it allows us to stay competitive, to innovate, and improve by using a simple and smart sustainable solution.
Now, I will be talking about some key problems faced by a manufacturing company. These are common in companies involved in forging operations. The first problem is a high scrap rate in forged parts. This means many parts fail to meet quality standards and must be thrown away. It wastes material, time, and money. With IR 4.0, we can use sensors and machine vision to detect defects early. This helps reduce waste and improve quality control. The second problem is an inefficient material handling system. Parts take too long to move between workstations. This usually happens because of poor layout or slow handling methods. With smart technology, we can use automated vehicles and better layout design. This will make movement faster and more efficient. The third issue is pressure and on delivery lag time. To meet deadlines, workers might rush production or skip inspections. Machines may also be pushed beyond their limits. Using AI-based scheduling and predictive maintenance can help. It keeps the process smooth without overloading the machines. The fourth problem is a lack of real-time quality feedback. If errors are only found during the final inspection, the entire batch may be ruined. With real-time sensors and monitoring, we can catch problems earlier. This helps avoid large losses and improve overall quality. In conclusion, these are serious problems, but they can be solved. Industry Revolution 4.0 offers smart solutions like automation, sensors, AI, and better planning. With these, companies can reduce waste, improve efficiency, and stay competitive. As part of our initiative aligned with Industry 4.0, our company has set 3 key objectives to enhance manufacturing performance and competitiveness. First, we aim to reduce waste and production defects. At Evolate, this means minimizing rework, excess inventory, and inefficient motions by adopting lean tools such as Kaizen, 5S, and value stream mapping. These tools help us identify non-value adding activities and streamline operations, especially in areas where precision and quality are critical. Second, we focus on improving machine uptime and productivity. One of the challenges in manufacturing is unexpected machine downtime due to issues like tool wear or lack of maintenance. To address this, we introduce predictive and autonomous maintenance programs along with digital Kanban systems. This ensures machines are maintained proactively, leading to more consistent output and reduced downtime. Lastly, we work to increase visibility across manufacturing processes. Previously, data collection was manual and often delayed. Now, we utilize Google Forms and Google Sheets as a Kanban tracker and visualize that data through Looker Studio dashboards. These shifts allow for real-time monitoring, better interdepartmental collaboration, and more informed decision-making. Overall, these objectives reflect how we are integrating Industry 4.0 technologies to create a smarter, more efficient manufacturing environment.
Assalamualaikum and hi everyone. So today I would like to present about the Lean tools. I am Emilia Liza binti Abdul Halim, 2021494606. For the Lean tools that we will use in our company, which are 5S, Kaizen, Jidoka, and also Kanban. So first, I would like to share about 5S, which are sorting, setting, shine, standardize, and also sustained. This is useful to improve our workplace organization in CNC, forging, and QC labs. It also can reduce waste and downtime. Okay, the second one is Kaizen, which meaning continuous improvement. Kaizen is actually we want to make improvement in forging line, for example, to reduce the scrap rate. Okay, the third one is Jidoka, which are automation. This is useful to detect problems automatically. So after that, we can stop the process and prevent defect products from continuing down the production line. The last one is Kanban. This is one to make improvement of flow, which is for materials from forging to machining. This can use visualing pull signals. Okay, for the next slide, I would like to share about visual lean system. There are 3 indicator color that we use in our project, which are red, yellow, and green. Red stand for urgent task, which is it need a required prioritized action one. The second one is yellow. Yellow stand for standard, so this need to follow the schedule for this task. The green one is low priority. Okay, we have already put these 3 indicator color as one of the information that are required in Google Form for operator users. Okay, for the next slide, I would like to present about quality improvement tool that had been used. We will use 5Y analysis. First, I would like to present about the problem. The problem is fork piston show micro cracks during ultrasonic inspection. So there are 5 Y that I use in this table. So first Y, we will ask about why are piston showing micro cracks. So it's will leading to because it's happened develop cracks during the fogging process. So the second why did cracks develop during fogging? So it will say because mold temperature fluctuate. And it also will be asked why did mold temperature fluctuate? Because thermostat control unstable. So we will ask why was the thermostat unstable? So it will say because sensor calibration beyond tolerance. So the last why did sensor calibration drift? So it will leading us because there are no scheduled preventive calibration program. So the 5Y analysis will leading us to the root cause.
Now, we are moving to the next part. I'm thrilled to share with you an innovative Industrial Revolution 4.0 system that leverages data to streamline operation and enhance efficiency. We call it Evo Sense Light. Evo Sense Light is like a system in our company. So, let's dive into how our work system works step by step. As its core, Evo Sense Light is designed to simplify and accelerate the process of managing industrial part and requests. It's a smart data-driven approach to an age-old problem. The journey begins on the factory floor, which the workers from the department requesting parts. Instead of cumbersome paperwork or manual requests, we have integrated and seamless digital solution. Workers can simply scan a QR code for parts requests using their mobile device. These QR codes direct them to a Google form for requesting part. This digital form, as you can see here, captures essential information like requester ID and parts ID. This eliminates human error, ensure accurate data captured from the get-go, and instantly digitize the request. Once request is submitted via Google Form, it's flowed directly into our central nervous system, the Google Sheet Digital Kanban Tracker. This is where the magic of data visualization and real-time tracking happens. As you can see on the screen, the supervisor receives a notification request from the system. This comprehensive spreadsheet provides a clear view of all income requests, including details like parts number, description, quantity, and the required data. The beauty of this digital Kanban is ability to provide a real-time, transparent view of all pending and processed requests, significantly improving visibility and coordination. Now let's look at the supervisor role in this streamlined process. Upon receiving a notification, the supervisor checks the availability of the material request from the supply department. Based on this check, the supervisor updates the status directly into Google Sheet. If the item is available, the supervisor changes the status into in progress. This immediately signs to the requesting department that their part is being processed. Once the item has been supplied, the status is updated to item received, confirming the successful delivery. If, however, the item is non-available, the supervisor states delay. This proactive communication is crucial. Instead of workers wondering about the status of their request, they receive immediate feedback, allowing for a better planning and resource allocation. These entire loops ensure that every part request is tracked, communicated, and managed efficiently, leverage data at every step. From the initial scan by our workers to the final status update by the supervisor. Evo Sense Lite brings transparency, accountability, and efficiency to our industry and reduce lead time. But how does this thing works? We will moving it on to the next part. Now, let's take a closer look at the heart of our real-time system, which is the Evo Sense Lite Digital Kanban Tracker. Every submission from the Google form is automatically populated into this share sheet. That includes important fields like part of ID, quantity, locations, request date, due date, and the assigned task type. One of the most important columns in this sheet is the status column, this is where the supervisors can update the progress of each request using a drop-down list. The options include request, in progress, delivered, delay, and cancel. We have applied condition formatting to this status, for instant visual recognition. Red means the request is the new or urgent. Yellow shows that it's in progress. Green indicates that it has been delivered. Grey is for cancelled tasks, and slightly orange, which are delayed. This color code visual system to follow Lean's Mureka principle of visual control, making it easy for everyone, from operator to supervisors, to immediately see what's needed, the action. We also include an urgency column beside the task tab to help prioritize critical tasks. You can think of it like traffic light. Red means urgent, yellow means for standard, and green for low priority. The best part is update all live. There's no need for back and forth email or lost paper slip. If a request is submitted at 9 AM, it's appeared in the sheet by 9:01, ready for supervised review. There are also remarks column where team leads can note progress update or specific follow-up action. This not only help with transparent, but also act as a record for internal audits and Kaizen tracking. This sheet become more than just a tracker. It's become a real-time command center for shop floor logistics. By digitalizing our Kanban system in this way, we can eliminate miscommunication, reduce lead time, and empower our operations to take control of their workflow. It's a low cost, no IT team required, but it gives us a full visible and full control. Now we are moving to the next part, which including Evolate Kanban report. Based on the Google Sheets, the update data are following that been pulled out to this Kanban report. Let's take a closer look at our part ID data performance within the Evolate Kanban system. At the top left of this dashboard, we have a tabular view of all parts, displaying details such as due date, quantity, parts name, parts ID, and the number of records per part. As seen in this table, the most active parts ID are sensor 10 and bearing 5, both with 2 records in the current dataset. Moving on to the bar chart on top of the right, which is this one. It visualizes the record counts distribution across different parts of IDs. In here, we are observed that a sensor 10 is the most frequently appearing item with a count of 7, followed closely by gear 3, injection 8, and seal 9. Items such as piston 4 and bearing 5 shows a lower activity around 2 or 3 entries. This visualization helps prioritize our high frequency components, especially when managing production loads, material planning, or anticipating procurement requirements. On the bottom bar of the right place was a location. This is the percentage of the location that mostly require the spare parts of the part that already been used at that place. As we can see, there are 17.1% in CNC compatible temperature sensor and high precision transmitter gear set, both with the highest number of 7 in each part, which require 7 parts that need to be replaced. Next, we are moving to this graph, which is type versus due date. As far as we know, the third one is July 21 of 2025 are the due date that need to be done by the workers. So we need the supervisor need to take the actions in order to reduce the lean management. Now, on the second page, we simplify and summarize the same part ID data using a donut chart. Here, we can see clearly that a sensor time accounts for 71% of all part-related records, followed closely by Gear 3, Injection 8, Seal 9, ranking between 12 to 14%. A lower contribution is seen from parts like Bearing 5, Piston 4, and Crank 2, all within 7.3% range. These percentage breakdowns give us a clear inventory and usage profit for each part. Just beside that, the total record counts is 41 and now currently, due to live action, are record 43, and we have been using this to identify the top parts driving activity in our Kanban system. Last but not least, the bar chart below reinforces this data again by showing part frequently visually, making it easier for us to quickly spot the key contribution. To summarize our part here, Sensor 10 and Gear D are the most dominant components in terms of system activity. This insight can support decision in inventory management, supplier prioritization, and forecasting future part demand. Going forward, we recommend placing a higher monitoring on top of contributors and adjusting replenishment cycle to avoid a bottleneck or overstock.
Today I'm going to present the problem that my company had to face and how to solve them. Here is the project sustainability and continuous improvement. The first problem is high scrap rate in forged parts. The affected area is forging line and heat treatment zone. First, we implemented the JDK, which is built-in quality, where the machine stops automatically when detecting any abnormal condition. Next, we implemented Kaizen, which is continuous improvement, where we implemented daily improvement meetings involving the operators and the QA team. Finally, is TPM, which is the total productive maintenance, where the routine maintenance is for forging machines and hydraulic system. The next problem is inefficient material handling system. The affected area is CNC machining and assembly line. We implemented the 5S system, where sort is to remove unnecessary items, set is to label the shelves, shine is the daily cleaning routine, sustain where we sustain the weekly 5S audits, and finally standardize for visual signs, flaw and markings. Next, we implemented just-in-time with Kanban, where we use Kanban card system, the productive pull system, Kanban boards and visual controls, and daily team coordination. Next, problem 3, which is lack of real-time quality feedback. The affected area is quality control lab and digital war room. First, we implemented IoT, which is the enable quality monitoring, where we use vision sensor to detect live data sent to digital war room for instant review. Next is SPC, which is statistical process control, where the chart is used to monitor the part tolerance. And finally, we implemented check sheets and histogram to track most common defects. Next is the final problem, which is pressure on delivery lead time. The affected area is precision, assembly line and supply chain. First, we implemented Haijunka, which is production leveling. This is to balance workload across both shifts and reduce irregularities in production speed. Next is value stream mapping, where it mapped flow from raw material to shipment to identify tool changeover and idle waiting time. Finally is SMED, which is quick changeover, where more production output per shift. Here is the benefits of the project. First is the productivity, where we increase the CNC line uptime. We also increase the turbocharger output. We also increase and optimize the material flow. For example, the 5S and JIT system will help move faster and smoother through the process. And finally, balance shift production, which is Ajunka, where we assemble across both shifts was equalized. Next is quality, where we lower the scrap rate in forged components. We also prevent defective flow. We also rework the reduction using real-time alerts. We also implemented SPC, histograms and check sheets, where the quality control team use SPC charts to track any issue. And finally, we improve the customer satisfaction. Next is manpower reduction, where the digital war room is for supervision in real time. Faster material access using the 5S system. Kanban eliminated constant monitoring, where the material request is now signaled using Kanban cards and visual boards. And finally, the visual SOPs is for clarity for the workers. Finally is time saving, where we lower the delivery time, faster part movement, less time on rework, shorter tool change time. Also, we have faster quality checks, where the parts are checked during machining, which reducing the inspection delays. And finally, less time searching for tools. That's all for me. Thank you.